So we were going to talk about reason score and distributed Bayesian reasoning. I was wondering whether you would find it interesting if I tried to give you a 30-second pitch on distributed Bayesian reasoning based on what I read in the doc. You want
All
to hear
right,
what
yeah.
my
Your
conclusion is?
understanding.
Yeah, and maybe show you just like one sentence or two. So I guess I'd say the purpose of distributed Bayesian reasoning is it's a scoring system that estimates agreement with a claim of a group of people, but it is based upon, it tries to calculate or estimate what it would be is if that community read all of the child claims or descendant claims, rather than just taking a naive score.
Yep.
All right. And then it weights the score, the kind of voting or individual scores of individuals based upon how much of the content they have read. Is kind of the way it does it in a non-mathematical description. Does that sound?
Yep. Yep. That's a key part. There's the idea of the informed opinions versus initial impressions.
Yeah. So when I was first reading your paper, I kind of got stuck halfway through, but I think your article, the most recent Medium article, was a lot easier for me to digest.
Which was that? The
most recent one you posted, I think.
the one about coronavirus?
Was it Medium? No, just the one about Bayesian reasoning.
On my website.
On your website, yeah, I guess it
Yeah.
wasn't Medium. I probably got mixed up with something else.
Yeah.
Yeah.
These are both works in progress. But the one that introduces the concept at a high level without getting down into the math, I tried to put off any serious mathematics for as long as possible.
Yeah, I never got past, well, I failed trig, so I didn't even get into calculus. So geometry was really the highest that I was comfortable with. So yeah, I never when I start seeing like formulas and stuff like that, even though I do coding and I'm used to variables and stuff like that, my brain just kind of seizes up and I have to force it to figure it out. So I find it easier with a kind of a written description.
Yeah, and I think that's the case for most people.
Yeah.
And most engineers, I think most career software engineers are the same as you, where rarely have we had to think in math. We think in code. And those are kind of different worlds.
Yeah.
Okay, so maybe let me I can try to summarize reason score in many ways. So there's many similarities, but it is not based on necessarily estimating. The premise is not what would somebody believe. Although I think maybe there might sort of implicitly be that sort of estimate, but it is trying to quantify what beliefs are justified based on a few what I might call heuristics. So if a claim is supported by many reasons that have been submitted, supporting reasons, pros, and there are no cons that have been submitted, obviously the pro side is better supported. And then there's some symmetry intuition there, right? If there's one pro, one con, and that's all you've got to go on, the pro and the con side are equally well supported. So it's trying to quantify support, but it's not necessarily linking that idea to probability. And then it's recursive, which distributed Bayesian reasoning also is. So if there's one pro, one con, but the pro has a counter argument, well, obviously the pro is not so well supported. But then if for the first pro, there's one pro, one con supporting that, then they cancel out. And then the exact formula, I'm not sure, because you get For example, at the end, you got to a situation where there's a pro and then one supporting argument for that pro. I wonder what your exact formula is, but so there's a lot of similarities, and I think that the key similarity is justified belief. What seems to be the belief justified by argument.
Yeah. Yeah, I guess the key difference, yeah.
So vote counts doesn't matter with reason score, right?
Right. Yeah, and just to mention, at some point, I do want to have a similar voting system in reason score, so that we can see when the score that Gulli Bot has doesn't match up with people's intuition, and then know when to dig deeper and kind of where to dig deeper. So I do imagine something eventually that where they can kind of score different items at different levels, and but I haven't quite decided on that, because I really want to force people to say, you can't just tell me that's false, you have to tell me why. And that's one of the keys of Gulli Bot, is that it forces people to say why.
Yep.
Because that's the only way they're allowed to affect the score. And I could have those votes not affect the score, but still a lot of people, I think, will go in and vote and think they've affected the score, right?
Yeah.
So I want that data, but I haven't quite figured out. I think what I'm going to do is I'm going to say, I'm going to give like a thumbs up and thumbs down next to each item, and they can, if they do thumbs up, then great. So then I kind of have a data point, and then I ask them more questions like, do you disagree with the claim? Do you disagree with the evaluation of the claim? And if so, why? Like, do you think it needs to be
Right.
higher? Do you think it needs to be lower?
By the
So,
evaluation of the claim, you mean what relevance, what we're calling relevance, and
well, it could also be the truth of the claim.
you
They could
say
disagree with the claim.
or you disagree with evaluation. So those are sort
Right.
of the sides
Yeah.
of scoring.
Yeah.
Yep.
Yeah, because sometimes when people say, oh, that's bad, I don't know if they're looking at the number that I assigned to the claim or the claim itself. Because they might just be hitting the thumbs down saying, I don't like that claim, even though it says it's a myth.
Yep.
So people aren't always, I don't know how deep they thought into hitting that button.
So I noticed that in your example, every one of those claims seems to be accepted as claims. What you don't see is arguments that are challenging the premise. Saying, I disagree that they're all challenging the relevance. I don't know if you noticed that.
Well,
actually,
I don't know that I'd say
uh,
that. So when they say that it'll divert traffic down streets, right?
yeah.
And then they choose to, I mean, I guess you could call it
Oh,
relevance.
there is the
It could be irrelevant because there's a side, they're adding a new street to take that traffic.
right,
But
yeah.
I kind of think of that as making it false. Yeah.
Well, yeah, that's interesting. That one is even kind of ambiguous. So in the terminology I've come up with in my essay, I just use the term premise argument and warrant argument. And that's new terminology. And I'm using, this is from the Tolman model of argument.
Yeah, I keep hearing warrant and I keep forgetting what it means.
That's just the evaluation of the claim. So the warrant is whatever takes you from the premise to the conclusion. It can be interpreted as an unexpressed premise. So in Stephen's system, he actually explicitly creates an entity in the system for the claim that B supports A, or that B opposes A. And I would call that the warrant. And warrant is one of those things where there's since, for 70 years has been disagreement about exactly what it means, but it's all kind of close to that. I think it's clear enough as a concept that I think it works. And the reason I use that term instead of relevance, because the Canonical Debate Lab is using the term relevance for whatever, or what I think you just said, the evaluation of the claim, right? Assuming the claim is true, how does that matter? What is that? Does that justify the conclusion? But I think relevance, the way I'd like to use it is as a measure. So if a claim has low relevance, if you say the moon is made of green, is not made of green cheese, that might be absolutely true, but completely irrelevant. The warrant, and irrelevant means you disagree with the warrant. The warrant is, because the moon is not made of green cheese, you should convert Elm Street to pedestrian, right?
Okay.
And that is obviously you reject that warrant.
Yeah. But are warrants only for arguments against relevance as opposed to arguments against accuracy or truth?
Yeah. So
when you're making a con or something, you could attack the truthfulness of it, but if you're attacking whether it's relevant, is the attack the warrant, or no, the warrant's the fact that you're saying that it is relevant?
Yeah, and the warrant is exactly, yep, it's the claim that this is relevant. And so in both cases, you're attacking a claim. Either you're attacking the explicit claim, the premise that was actually stated, or you're attacking this implicit claim that it's relevant.
Okay. Yeah, so in the canonical debate, we draw it in, it's you have the claim and then the child claim, and it's attacking it, and then you would make another claim and just point it to the edge between the two,
Yep.
rather than to the other one. So the edge itself is kind of the warrant.
Yep. Or you can call it the relevance, but then you can't say something like the warrant is the claim that this premise is relevant. So that's why I think it's useful to have another
word for it.
Otherwise, relevance serves both as a measure and as an identification of a claim.
Yeah, I'd have to think about how that impacts anything. But I'm not sure that's an important point at this time, because it's probably just in different ways that we think about and express them. But I was thinking, I guess I was wondering, so then how do we see these two scoring systems kind of either working together or not working together, just being alternatives?
Yeah. So I was thinking that distributed Bayesian reasoning reduces to relevant score possibly in special cases. The reason, so let's say, for example, every argument has exactly one vote from one unique person. Then I think the results will be very similar. I need to do some more evaluation, but obviously in certain cases they'll be similar. But where distributed Bayesian reasoning really differs is it does take into consideration the number of votes, and that can have a big influence.
Well, when someone votes in it, are they just voting agreement, or are they saying a percentage agreement? Or
just agreement, and the percentage is derived from a ratio of votes. And so the relevance, we would measure relevance in distributed Bayesian reasoning as the probability that someone agrees with A given B versus the probability that they agree with A in general. And so B, acceptance of B increases probability of acceptance of A. In that case, we would say subjectively, based on people's opinions, B is relevant.
So what's the final score mean? So if you roll all this up, is that saying that top claim is justified or acceptable, or
Yeah, I use
what? How
the
would you
term
express it?
justified, and it's justified because it is what that particular group of people, a randomly selected person, it's an estimate, it's trying to estimate what a randomly selected person from that group of people would believe, the probability that they would agree with the top level claim, given they had seen all the arguments.
So, but it sounds like when you're voting on individual claims, if it's just agree or disagree, what happens if I think it's like likely? Is anything above 0 agree?
I could certainly add that, and it would just be a weighted vote. You think
Okay.
75%, it'd be like 3/4 of a vote
Mhm.
for and 1/4 of a vote against.
Because the more I do this, the less I evaluate any claim at 100% agreement.
Yeah. Yeah.
So I would be frozen looking at your system on the, on one down. Well, it's not 100%.
So that is a good point. I think with large numbers of people, I think the results aren't going to be much different if you allow people to give fractional votes. Because instead of a lot of people giving 50% vote, you'll have half the people giving 0 and half the people giving 1. My intuition is you'd probably get similar average with a lot of people. But that's a good point. There is that psychological thing where a lot of people just won't vote if you force them into
Maybe.
certainty.
And then is it agree, disagree right now? If I could explicitly say agree, or do I only hit the ones I agree with?
You can explicitly agree, explicitly disagree, or you don't vote. Now, another difference is distributed Bayesian reasoning separates out, makes a distinction between premise arguments and warrant arguments. And that's very significant because a premise argument can be argued by a completely separate group of people. And then the resulting score, which is a probability that someone would believe in premise B, given all the arguments made for B, is then plugged in to calculate the probability that someone would believe in A.
So yeah, in reason score, there is also internally a concept of relevance versus accuracy, or truth, however you want to say it. So it is in there. So you could, all the evidence could be that it's true, but you could still come in and say it's irrelevant in the context of this debate. It's just that complexity is a little too difficult for most people as far as when I'm explaining it on the first walkthrough. So I save relevance for later, and the video just doesn't get that far into it.
Yep. So I think that video is a good introduction because I think in a lot of arguments, especially when they're more, when people are not too ideologically divided, if it is, local civic discussion or a team or a company, people are discussing things, people tend to not make false statements. People tend to make statements where other people disagree, not with the truth of the statement, but with its relevance. So, and that's most of what your example is people making a claim about, traffic that usually are true. And sometimes someone will make a mistake and you'll say, no, that's not actually true because we can do the railroad. But for the most part, it's more of an evaluation of the relevance. And I think it's easy to describe the process. I also give an example of a jury trial where before the jury's brought in, all the facts are established by the court. So a lawyer can't say the DNA evidence was found valid by the lab unless that is actually the case. They can't make knowingly false statements. And so then it's all really just evaluating, accepting all the premises and evaluating their relevance.
Yeah, you use that in the example, but in the actual kind of use case, though, people are also arguing against. It's not always the warrant that they're debating against or scoring,
always.
right? Yeah. Okay.
And so what makes distributed Bayesian reasoning distributed is the ability to make premise arguments. Because you can now aggregate arbitrarily complex, large argument trees, as long as, but you can only separate these, what I call subjuries. You can only carve those out for premise arguments. So the problem is, if you have a lot of claims that everyone agrees with, like a lot of pros and a lot of cons, and you're trying to evaluate, okay, now overall, how should we score this? Now, or even if not everyone agrees, you have all these claims and you have the subjury has given you a percentage for each one. Now what do you do with that? And I think that's actually the hardest part. And I think I have more or less worked out a reasonable way of aggregating those results. But one thing to consider is, are these reasons independent? So if you're taking a model of probability, you've got, okay, the probability someone agrees with A given they agree with B is high, right? So B is very relevant. And C is also relevant. Let's say these are two pro arguments, right? But how do B and C interact? Are people that agree with both B and C, and there's actually kind of limits to how that could be. B and C could essentially be redundant, either literally redundant, like just the same way of saying two different things, or kind of maybe semantically redundant, where B implies C, right? If B is true, C is true, and vice versa, or somehow basically they contribute the same amount to the argument. So the probability of someone believing in A given B and C is identical to the probability of believing in A given B or given C, right? So there's one extreme. They could interact where the one kind of cancels the other out. That'd probably be the case with a pro and con argument.
Right.
But it could be an example we were talking about once, where someone was saying we should take Jimmy to the hospital because he was stung by a bee, and he's allergic to bees, right? Stung by a bee by itself doesn't mean you should go to the hospital, and being allergic to bees by itself doesn't mean you should go to the hospital. But those two together, in argumentation theory, those are called linked arguments, where they depend on each other. You can't really evaluate the relevance of one on its own. They kind of, you need to know how they interact. So in that case, the only way to know how they interact is to look at people that vote on both B and C and see the probability that they'd agree with A, at least, with this.
Well, they have to vote on B, C, and A at some point.
Exactly.
Right?
Yes.
Yeah.
Yep.
So you need a subset, a jury, sort of, to do the voting, and then you distribute. You estimate it for everyone else.
Right. So the top level jury has to vote on A, B, and C. So you need this probability distribution of a joint probability distribution on A, B, and C, and then you can do that that probabilistic calculation.
Yeah, what's interesting in reason scores, I have to explicitly call out the relationships in order to do the calculations. Well, you're able to aggregate votes to estimate that. That's an interesting difference.
So another thought I had for you, I was just doing this thought experiment yesterday. What if you have 10 pros that are submitted and each gets one vote, but there's 10 different people voting, versus one pro that gets 10 votes
In reason score or in,
or just in general, like
yeah,
how should we evaluate that? What does that tell us
yeah,
about?
because
Uh,
reason score doesn't have votes, so
right. Yeah.
so that could never happen. So the system would assume that, the 10 pros are 10 times heavier than the single pro or the single con until someone comes in and puts reasons why the other ones should be heavier or lighter
Yeah.
or are duplicates.
I was thinking a lot about that. Because it's reasonable to think if there are more greater quantity of reasons, that is evidence to me. And here I'm trying to infer always the probability that someone who was aware of all 10 of those reasons would agree with A, right?
Yeah.
Or someone who was aware of all the reasons would agree with A. And certainly that having more reasons seems like it should be evidence. Yet I do think those two situations probably should basically be evaluated the same, should result
I
in the
mean,
same score.
I think the fact that you're measuring people's conclusion of A and then you're looking at also the people's conclusion of those 11 items below, I think that you're abstracting out the individual weights between all those different pros and cons. So I would think you could ignore the number of pros or the number of cons, because I can't think, because you're solving that problem through looking at the relationship between the votes on A, the votes on B, and the votes on C.
Yeah.
So yeah, I wouldn't think your calculations to take it into account explicitly because it's kind of already rolled up in the formula.
So that's what I'm thinking. And the way I describe that is in both cases, you have 10 justified votes, not not a popular vote. A popular vote, people, could be 1,000 people that agree with A, but there's only 10 justified votes in both cases. And so if it was, 10 pros each got one vote, 10 cons, by symmetry, you have 10 justified votes on either side, and they should cancel out.
It'd be interesting to do the math because I'm also wondering in that situation if you have one individual person voting on both, you don't have a single person that has, and I know you don't need it, but you don't seem to have an overlap of people that made similar, like, is there a minimum amount of the data that one person has to vote on in order for their votes to be able to be balanced against the other votes in the system?
Right. Because
Or are
obviously
they,
what's most informative is people voting on multiple items.
yeah.
And especially if there are a lot of items and we don't know how they interact.
I mean, so I'm wondering whether, I don't think if everyone voted on just one item, I don't know if in that example you were thinking they also voted on A or not. I don't
Yes.
think you could draw any conclusions based on that.
Hmm.
But that's an intuition. I don't have a reason for that. But I think you have to have some, in order to, you have to have some, the overlap of the sets that two people voted on. You have to have some sort of overlap in order to determine the relationship, in order to determine the final score.
Yeah. That is basically how I've been thinking. But then I'm trying to crack the nut of what if you do have really sparse data? So sparse data is you don't have a lot of
Yeah.
overlap. So you want the joint probability distribution A, B, and C. But what if you have 100 items and things can get who knows how complicated, that are all submitted at the top level. And then for each of those, there's counter, supporting arguments, but those are sparse. And so one possible solution is to say, well, just design the argumentation system to try to obtain the data that it needs. And so, once you start seeing, okay, these two pros are getting a lot of votes, but we don't have a lot of data on the overlap, It's submit notifications to people, and try to get people that have voted on B still get their vote on C.
So
And
when I hear you talking about sparse data, my thought is that you're spending time on something that could be deferred. But it depends on your, I guess, I don't know, perfection level on this project. So like, the startup mantra is, have a hypothesis, go and experiment on live people and then move on. And that doesn't always work, because if you're building like if you're building a cell phone and it's been done before, you use off-the-shelf parts, sure, do that. If you're building a new type of cell phone that's never been done, there's a certain amount of R&D before you can even show it to anyone. So that's a scale. And we often talk about how much to do this, but I was just thinking that the sparse data question is, if you want to get moving on this, I would actually just kind of set that aside and wait till you get there and focus more on doing a test. How far are you on this? Is it just the idea in the documents you've written so far?
yeah, mostly just the idea. I mean, I have messed around with some code, just some back end, the database, but haven't developed any sort of front end.
Because I was thinking that you could put this system on top of some data like Kialo, and it should, if people vote on it, it should work, right?
Yeah.
The problem with reason score is that the weighting system depends on the positioning and the arrangement of the claims, and people weren't thinking that when they built the structure, right? They were just kind of responding to each other. So my gut reaction is that if you applied reason score to Kialo, the scores would be all kind of useless, and someone would have to go in and move them around. Although someone's have to go in your system and vote anyway, so maybe I'm wrong in that. But I was just thinking that might be kind of a quick test, is to, not quick, but
you know if that particular data set is public? I'm sure that I know that there are public data sets about arguments. There's even a new field called argument mining, where people go off into like social networks and try to extract from tweets and whatnot argument structure based on different models of argument. And if I could find a compatible argument structure with votes, it would be great if I could find one that did make the distinction.
I mean, I think if you're doing an experiment with a small set of people, the data doesn't have to be, you don't have to have permission. Only if it's fair use in that case, right? If you're redistributing it and you're replacing it, then now, of course, they're also European, so they might have different laws, but also it's kind of hard to prosecute you. But I don't think it's that bad if you invite 20 people into a closed system and say, hey, vote on this and let's look at the numbers. And then you do a thing and say, oh, we use Kialo's data, link to Kialo, but don't publish their data, but publish your results. I think that's fair, like a lot of, even without their permission.
But I wonder if, does Kialo provide data sets?
I don't think so, but it's pretty easy to extract.
Yeah.
So I've extracted it before for
just as a crawl.
Well, yeah, I mean, so actually last time I checked, I haven't checked in a while, they do a JSON fetch. So you just watch for that fetch and grab it when it comes in. And I think they do the whole tree. So it's just like I could create a plugin.
Basically, there's an unofficial API that the web is using.
You can kind of hit their own backend API, and I think it's fairly easy.
That's cool. So that might be a good data set. But what I'd like is a data set that distinguishes between premise and warrant arguments.
Right. And they definitely don't have that. That's a really good point. That's another problem that reason score would need with the data set. So that's interesting. Maybe we should collaborate on building a data set that we could both use, or finding one.
Yeah.
I don't know if because I allow attacking against the premise, so I would convert the warrant into that. Attacking against, it's the same wording, I guess. So I do need to know whether they're attacking the the claim or its relevance. And in that case, it would be whether it's attacking the claim or the warrant in your case, I
Okay,
think.
yeah.
So that's another piece of data I don't have. And then also the weighing of the arguments in my system. If someone says, well, this argument's more important than the other one, I mean, that may be written in text. Although I don't know that people even do that. Do that? I don't think in like Yellow they do a more meta thing saying, well, that's not as important. You know, increasing the profits of the local businesses compared to kids being killed by traffic going down the residential streets, right?
Yeah. Yeah, I would be surprised if there's a data set that has that, because I just don't think many systems are that sophisticated. They don't provide that sort of input for
Would
users.
does that apply? That doesn't apply in your system at all, because you can calculate that based upon the combination of their voting patterns.
Right, but I think my system could be expanded slightly to allow that as the input instead of binary votes. And
well, although if you don't have an explicit use for it in your system, like if you're building a UI, I'd suggest against it, just because if we're doing a shared thing, maybe, but you don't want to complicate your UI with something that you don't explicitly use. That's what I'm saying.
Yeah, if you don't know, it's going to really
it's hard enough to get people to enter stuff in there. Every button you add is or every choice, you get that cognitive dissonance. I mean, if we decide we're going to start collecting data.
What you said about people being frozen because they're not certain. And another thing that I may need to want to add to my model is the ability to say, I'm not sure, and to treat that as differently than non-vote. And the reason is it's still an informed opinion. You've at least seen the argument someone has made and said, well, I still believe in A. I'm not sure if B is true or not. And exactly how I work that into the model, I'm not certain, but I think that could be pretty valuable. If a lot of people don't vote because they're not certain, that might get us some more data that I think can still get us contribute to the overall score.
Yeah. So how in the UI do they vote against the warrant versus against the claim, or do they?
What's interesting is that you don't have to.
They don't.
You don't have to explicitly vote on the warrant. What you vote on, and how exactly the UI works, I think it has two possibilities. And the one that I'm kind of favoring is that, well, first of all, there's the idea of progressive formalization that CDL talks about. So to start, you don't need to make a distinction. You just make an argument, and that argument attacks or supports, opposes or supports another argument, and you don't specify whether you're addressing the warrant or the premise of that other argument. But you can, and it doesn't, but then what you can do is an argument can be, instead of a comment, your response, and the response doesn't even necessarily have to be seen as an argument, right? You say you agree and then you comment, and presumably that comment is a reason you agree, or you say you disagree and you comment, and that's the reason you disagree. And then people vote on your comment, and that vote is saying, okay, I agree that this is a reason. I agree with A, and I agree that B is a good reason to agree with A. So when you vote on a comment, you are saying you agree with the premise and the warrant. If you were to disagree, that implies logically that either you disagree with what they said, or you disagree that that's actually a good reason to agree with A. But initially that distinction isn't made. And so you have almost a simpler argument model, more like the Dung model, where you just have people that agree. It's like the Dung model where you can, but arguments can both support and oppose instead of just attack. And then you have votes on each arguments in that graph. But then I create the option to split out the premise. And you do that by responding to a comment with a poll. And so someone says, at some point says poll, and then the prompt for the poll is, do you agree that? The prompt encourages you to make a claim that is a clause. And a clause can fit into a sentence after, do you agree that, or do you think that? Or who thinks that the traffic will actually be diverted down this other street. And that is your argument. And your argument is a question. And then, of course, you vote on it. And you say, I agree. And now that you've voted on, let's say that's B. So you agree with B. B is now a separate premise. You agree with A. So the system has the information it needs to say, the probability that someone agrees with A, given they agree with B, is this. Probability that they agree with A, given they disagree with B, is that. And it actually needs both of those numbers to do the calculation. And once you've created a poll, then it's just, that's a separate URL. People can click discuss under the poll and discuss that poll, and that claim gets a score. Or you don't have to discuss the claim. You can just say, I agree, but then you can respond to that comment. And you can say, yeah, but, so once you've said, I agree or disagree, then you can say, I agree, but, yes, we can divert that traffic, but this other thing. Or you say, I disagree, at which point you probably don't need to respond. At that point, you go into the poll and you explain why you disagree. And so you make your premise argument. But you could also respond and say, I disagree, and besides, and then you can add another warrant argument. So another possibility is your reply options could be, so instead of creating a separate poll, there's the agree or disagree buttons. But when you click on disagree, a little submenu comes up asking you to choose one of two options. Disagree, as in not true, or
irrelevant.
Agree, but. And it's encouraging people to think, okay, do I really disagree with what they're saying, or I actually agree with what they're saying, but, and that's how we distinguish between the two types of arguments.
It all kind of made me think of what happens after the initial or in subsequent kind of voting passes. So someone's gone in, done some voting, someone adds a new con kind of down in the stack. If that person reads that con, maybe votes on it, or I'm wondering, first of all, because it sounds like naively your system would then weigh everything, even though they haven't revoted at the top one. And if that changed their mind.
I'm not following your example. So
A, B, and C. So A is the conclusion.
Yep.
And then
That's
B
what
and C are premises.
Yeah.
So let's say that someone has voted on all of them, A, B, and C, and then someone adds in D, and the person votes on D. Maybe their mind has changed about A, but they didn't go back and vote on A to let you know their mind changed.
Yeah, okay. Yeah, so I think there should be prompts. Even at the first level, right? You vote on A, and you agree with it. Someone gives a con B. And then at some point the system realizes, well, a lot of other people agree with B, and it's actually changing their mind about A. So B seems to be relevant. Sends you a notification, and it says, hey, look, you agree with A, but what do you think of this? And then after you vote on B, it'll prompt you. So you say, oh, I agree with B. And then you say, do you want to change your vote on A? Or if it's in a social network, you say you shared A, and it was some rumor, and someone submits B and notifies you, look, a lot of people agree with B, and it seems to be a good reason not to agree with A. You already shared A. You want to retract, making a retraction. And I think that would be really powerful. I think social media needs that because people,
Yeah.
well, and it's kind of a diversion, but yeah, definitely prompts to change your
Yeah,
votes.
and I was just wondering though, you're gonna have to decide how to handle the math if they don't respond to that prompt. So are you gonna discount their vote on A because you haven't
Absolutely.
got a clarification, or
Yeah. And
leave it as
the
is?
idea of the informed opinion and the justified opinion, the informed opinion is because now, um, I mean, all we know is that their initial impression was A, right? And and in order for their vote not to be discounted, they can vote on B um, without changing their vote, and then their vote is not discounted because then that changes the relevance of B to A. Now the system says, the probability of someone believing A, given they believe B, is now not so low, right? And if enough people agree with you, you can actually go
Yeah.
and
I'm
swing
just
the
thinking,
vote.
if they don't re-vote on A, it sounds like the math would, and let's say you didn't discount it at all, the math would kind of it would mathematically make that be less important in the overall thing. Because you'd say this person saw it, this person agreed with it, but it didn't change their opinion. So the net result would be it's less powerful. There's less of an impact.
Well, I think seeing B, agreeing B, and not changing your vote, I think in terms of how votes are weighted would be the same. And there's an analysis that I've started to dive into, like to see how the implications the math has on like how democratic this process is. And so it is the same. And maybe to give you a simple example, let's say only 2 people voted and everyone that agreed on B disagreed with A. So now the probability of A given B is 0, right? Now you come in and you agree with B, but you still agree with A. So now it's 1 out of 3. Now, if 2 more people like you come along, now it's 3 to 2, right? It's 3 out of 5. And so your vote actually is weighed very heavily. It's weighed more, and there could be 1,000 people that voted on A, but if nobody voted on B or any of the arguments that were made, only the informed votes count. And actually, that's not quite true because I think you need to do something called Bayesian averaging, which accounts for sparse, small amounts of votes. Right? If only 5 people have voted, it doesn't necessarily tell you. It's not a lot of evidence, right? 1,000 people agree with A, and the 5 people that saw B, 3 of them disagree with A. What does that really tell you? So you need to. There's sort of I think there's a good technique for essentially what's called Bayesian averaging, where the votes of the subgroup regress towards the mean.
There was another thing that does that. I was thinking about incorporating it into reason score.
Wilson score.
I can't remember. I will not remember the name, but in general, it's the fact that in order to have things go back to the mean, like in Gulli Bot, instead of having a pro be 100%, like if the system always assumed there was a con there, whether it wasn't or not, then it would mean the pros would slowly kind of go up until it reaches some normalization to overcome that assumed con. There's some problems with the math. Gulli Bot ended up being named Gulli Bot because in the math I had to have it assume that every statement's correct until it has a con, because its score is determined by its children. If its children isn't at 100%, it can never reach 100%. So its child cannot, if you keep going down it, if the leaves don't start at 100, it can never get to 100.
Right.
Yeah. So, but I was thinking about going against that at some point, where if there's at least one pro, I throw in a con. But then everything gets screwed up.
Well, so what the Bayesian approach says, I have some prior beliefs. My prior beliefs, without any evidence, are that there's probably some pros out there, probably some cons out there. They're probably equally weighted, although that necessarily doesn't need to be your prior, right? It could be, for example, you might find in a certain forum where people make claims. In the long run, claims tend to be accepted more than they're rejected. And you can definitely see that in contexts where there's higher trust. If someone on a corporate forum says, this will cost this much, 90% of the time people actually agree with that claim.
Yeah.
And so in that case, your priors are already weighted towards believing that this claim is true. Or your priors could be, that you think it's equally likely that when all the arguments are made, they'll be equally weighted. And then you have a prior on like what that distribution is, like how far the final score will be from the average, long-term average, how much of a variation there is. And so Bayesian inferences always starts with a prior, and then every data point is just a piece of evidence that pulls you away from your prior, unless it's exactly consistent with your prior, right? But and so a single argument shouldn't necessarily pull you to 100% pro, 100% con, and the math would be determined by what your probability distribution is, and then what your likelihood function, like what does that actually mean that there was this argument?
Yeah. We're getting close to our hour. Is there anything what are you looking for to help you with your projects right now?
So,
are you looking for data stuff, or are you still just thinking it through?
Yeah, I'm trying to, and so what you said before indicates I might be on the wrong track and trying to be too perfectionist. But what I'm trying to do is have a very rigorous justification for the final algorithm I come up with. I'm even looking, I want a white paper, something that has the quality of an academic publication that would, we could look at where an academic in the field of argumentation theory or judgment aggregation or Bayesian inference could look at that and say, yeah, well, that's actually valid. And the reason for that level of perfectionism is my overall plan is to create a vision for a system. Here's something that actually could be built or built into existing social networks, where someone could come along, read the white paper, say, oh yeah, I see why this would work, and I see how I can build it. And then my plan is not necessarily to create a new social network. My plan is to, and then it could be, for example, one possible future I see is that Twitter has their Blue Sky project.
Mm-hmm. Yeah.
And the future of social media could be decentralized. I've even seen proposed legislation where all social networks need to essentially open up and provide APIs. And I see a future where all social networks it's basically this one decentralized Fediverse where you can use any client to access all the social networks out there. And what distinguishes competitively the different clients, who wins in this space, is the person that has the better user interface and the better algorithms. The algorithms that gets you, that altogether provides in the long run the most benefit to users. And right now, social networks are addictive but not beneficial. That's, I think, in a lot of documentaries and articles about how that's the case. And so, in the long run, it might just be a client and there's the existing decentralized social network. So it could be, for example, just essentially an algorithm or a moderation layer for Mastodon,
Right.
or for the Fediverse, could be built into Mastodon. So there's a lot of different ways I could go. But what I'm trying to do is really have a compelling, rigorously justified, compelling vision and an algorithm that really it's convincing and justified. I'm making this claim. We're estimating what the average person would believe. That's a pretty bold claim, and I really want to strong
The
justify.
average person that spent the time
Yeah.
reading everything.
And if they could, obviously, eventually, your brain runs out of space.
Right.
That's why this is so powerful. This is,
Yeah.
If someone's brain had infinite space, I'm still justifying the claim here that hypothetical, the infinitely intelligent person would come to this conclusion.
I don't know if it's clear that Gulli Bot has that same sort of distributed reasoning potential. Is that clear when you read it?
Well,
in a different way, but
yeah, but I think for me, the challenge is, how do you deal with situations where you have very large numbers of pros and cons, and you can't really see how they interact unless you have votes on all the combinations.
well, so in Gulli Bot, you're explicitly saying how they interact. So what you're saying, what I'm saying is that someone, when they entered it, are saying, first of all, the pro or con, and whether it's attacking the warrant or the claim. And there's ways to say this claim is more important than its siblings or less important than its siblings. And then you can argue whether that claim of whether it's important or not or less important, you can argue that. And then the score all rounds up. So you can then look at a tree of claims. You can look at the top layer and say, I agree with that, I agree with that, I agree with that. So you don't need to read any of those thousands of claims beneath that.
Right.
But
yeah, and that's because you can separate the warrant and the premise arguments. Mm-hmm. Yeah, so that does, even though I don't 100% understand the score, I see how, because I see how you can achieve that same.
If you agree with the top of the branch, you don't have to read all the leaves of that branch.
Right.
So that you can quickly take two people that have trees and say they disagree here, 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 and here's the missing claim. I mean, not easily, because it's probably all written incorrectly, and that's where Marc-Antoine's tools come in. But two people looking at the same data set could quickly find out where they disagree.
Yep.
So then you can, and if I wanted to have trust that the scientists went in there and said that study was accurate, then I don't ever have to open it up.
Yep.
Say, oh, okay, I know my friend Bill has looked at that branch, and I'll just assume he's got it under control.
Right. And then there's great power if you say, hey, I think this study is true, and that's why I believe in this conclusion, and the system tells you, hey, look, your friend Bill and all the people in your social network that you trust seem to be leaning towards that this is not actually true. What do you do now? How do you revise your belief?
Well, so the interesting thing between the two systems is that Gulli Bot does force them to say why whenever they want to discount something.
My system,
which may be a burden.
Discounts. If you don't provide reasons, your votes are discounted.
Well, no, is it? Because if you have A, B, and C, if I vote on B, or are you saying in reason score, or are you saying
in distributed Bayesian reasoning, if arguments A, B, and C have been made, let's say in a single argument thread, and you don't vote on all three, then your vote is essentially not counted.
Right, but everyone can vote on A, B, and C, and the people that are saying that are disagreeing with B don't have to say why they disagree with B.
Right. Yeah, and so if that's the case, your vote counts in the top level jury to determine the relevance of B and C to A, but you have absolutely no say in the determination of the acceptance of B, unless you go in and give a reason why you agree or disagree with B. And then in that case, your vote can have weight in both ways.
Yeah. So when you're voting on B, you're just voting on the warrant, not on its truth.
If you agree with B, and you agree with A and agree with C, let's say, what you've done is you voted on the premise B, and you voted, basically your vote has contributed to the relevance of B to A, but you're voting, the fact that you accepted B does not actually count in the final acceptance of A, unless you justify your vote on B with a premise argument. Unless there are no arguments, right? So if no one agreed or disagreed with B, or if no one disagreed with B, or no one provide any reasons, let's say 50% of people agree with B, but nobody provided any arguments. Then in that case, the acceptance score of B is 50%. So people's raw votes are then counted, because there's no other way to estimate what the acceptance of B would be.
Yeah.
But if someone does go in and provide a pro or con for B, and you haven't voted on those pros or cons, your vote on B would lose weight. And there it's the Bayesian averaging. So your vote on B still has weight, but the more people vote on, let's say, G, which is a con for B, the less your uninformed vote has weight in the final acceptance of B.
Yeah, but if you have a group of people that they still all go and read them and don't, they can still, I mean, in the end, they could still all disagree with a claim and not say why.
Yep. In that case, there could be 100 people that disagree with B and didn't say why, and their votes would be discounted.
I don't see how their votes are discounted because someone else put a reason on why they do agree with B.
Exactly. Yep.
But if they read it, so you have A, B, C. So you have A is the conclusion, B and C are premise. You have a D, which is a premise to the conclusion of B.
Yep.
If B is a pro, is supporting, then if people vote on B and vote on D, then their claims are the same weight. If they disagree with D and vote on B, the claims are agree with B, aren't their votes the same weight as someone who agreed with both?
Yes, but someone that didn't vote on D, they will have less weight.
Yeah, but if we assume that everyone's voting on everything,
then the weight
there's no, I guess there's an incentive to put stuff in the system, because once you put something in there, only the people that look at it are weighing it.
And it might actually influence people. People might not have been aware of D.
Right.
And so if everyone votes, now you don't just have hypothetically what the fully informed person would conclude if they read all the arguments. Now you actually have, well, you're still estimating, right? You still, the people that vote are still sort of a sample of the hypothetical population of all people, right? But now you actually know, well, and you can actually see after voting on D, maybe some people changed their vote on A, or maybe they didn't. But now we know, at least for this group of people, the probability of A, given they voted on all the premises is this.
Yeah, so I am starting to put more data in Gulli Bot. I might have you look at my data format and see if it's something that you could then use this data if you want to run a test.
Yeah.
It's not still not crowdsourced, so it's going to be a small subset, but we're going to start having like groups of 10 to 12, an argument tree of 10 to 12 claims.
Can still see if the calculations match intuitions and also match reason score. That'd be interesting.
Yeah. So yeah, so whenever you have the bandwidth or the desire, feel free to reach out for me and we could see if, and I guess you could probably just kind of look at the site and see whether you think the way it's filled out. Although I guess you haven't seen the edit interface. So there is somewhere in there you say whether it's a relevance or true, I can't remember what I called it. Confidence or relevance is what I called them in the system. But yeah, feel free to, if that data is ever useful to you, I could certainly make it available.
Yeah. In the end, my algorithm is not that complicated. So when I have some code that's ready to take in some input, that would probably be interesting.
Yeah. Cool.
All right.
Well, it was an interesting conversation. I appreciate you making some time.
Yeah. Likewise. All right. Well, yeah, I guess we'll just stay in touch. I'll keep on sending periodic updates and let you know if I have some code I want to test with data.
Yeah. And you don't mind if I post this up on YouTube as people seeing me work in public, right?
No, that's fine.
Because you're posting all your stuff out in public anyway. So.
Yep.
Cool, man. All right. Well, I'll see you around at the canonical debate meetings.
All right. I'll see you around.